So this section follows on very closely from the previous section where we were looking at error intervals. So if we had, let's say, a parcel's weight and it had been measured to 105.5 grams and the display showed values that had been rounded to 1 decimal place, for example, then we were able to identify that the error interval would have to be 105.45 is less than or equal to x is less than 105.55. So it was understanding that the heaviest that the parcel could be would be 105.55 grams, and the lightest it could be would be 105.45 grams. Now, part of this is also going to be thinking about continuous and discrete values here. Okay. Now, what I mean by that is that you might have been going, well, if I say that the heaviest it could be is 105.55 grams, if it was 105.55 grams, it would be rounded up to 105.6. So that doesn't really make sense. But it's coming down to the fact that the heaviest it could be is 105.549999999999, etc. grams. Okay? In fact, you could write it down like this, right, with a recurring 9 if you wanted to. But 105.549 recurring is equal to 105.55. So when I'm saying that the heaviest it could be is 105.55 grams, that's accurate. Okay, I can say that. Now, when I say that we're going to be looking at discrete setups as well, it could be that we've got something in, let's say, in monetary terms. So let's say it was £75 rounded to the nearest pound, to the nearest £1. Okay. Now, if the context is in coins, let's say, so I've collected all these coins up and I've added them all together and I've got £75 rounded to the nearest pound. Okay, what could I possibly have had? Well, the lowest it could have been would have been £74.50, right? So if I'd had £74.50, I would have rounded that to £75 to the nearest £1, because that's the units column, and the one to the right is 5 or more, so I'd round that up to 75. So it's got to be greater than or equal to that. The largest amount it could have been, it doesn't really make sense for me to put this. I mean, I take that back. It's not that it doesn't make sense to put that, but we can be more accurate than that. Okay? Because if we're talking about coins here, then the actual amount that it could have been is not 4999999, right? It would be £75.49. Okay, because I can't go into any smaller denominations. So that is much more accurate than saying it's got to be less than £75.50. Okay, so actually we can put less than or equal to on both ends of this problem, of this discrete problem. Okay, so we will be coming across both continuous problems like weights, volumes and lengths, but also discrete problems like coins, like number of people, for example. Okay, so it's really using those error intervals in a more contextualized kind of way. And when we get into the second half of this section, we're going to be looking at calculations involving error intervals and how rounding can cause quite different answers depending on what values you've used.